Have you ever stopped to just look at a building? The one you're in right now, maybe. Think about the sheer crushing weight of it all. What is actually holding it up? Well, today, we're going to pull back the curtain on the invisible physics that keeps our entire built world from, collapsing.
I mean, it's a pretty wild question when you think about it. You've got these massive skyscrapers, giant bridges, even your own house. What is literally stopping all of them from just sinking straight into the ground? Believe it or not, the answer is hiding inside this one simple sentence. It sounds kind of straightforward, but it's packed with meaning. And it gives us two clues to follow: the idea of loads and how you transfer them to the ground. So let's start with that first one.
All right, first up, what in the world is a load? I know, it sounds like a common word, but in engineering, it means something very, very specific. See, a load isn't just the dead weight of the concrete and steel. Oh no, it is everything. It's you, me, all the people walking around inside. It's the furniture, it's the wind pushing on the walls, it's even the weight of snow piling up on the roof. A load is the grand total of every single force a building has to fight against, every second of every day.
Okay, so we've got a handle on the load. Now for that second piece of the puzzle. What does it actually mean to transfer that load down to the ground? This is where things get really interesting. The best way to think about it is like a journey. For any building to be stable, there has to be a complete, totally unbroken path for all those forces, all that load, to travel. It starts at the top of the building, moves through the frame, and its final destination has to be the earth itself.
And this journey, when it's done right, happens in 3 perfect steps. First, some kind of force gets applied to the building. Second, the building's skeleton, its columns and beams. They act like a relay team, passing that force down, down, down. And finally, the foundation safely hands off that entire force into the ground. When that works, you have a perfectly stable building.
So here you can see the two possibilities. On the left, that's our successful journey, a clean, unbroken path right into the ground. But on the right, that's what happens when something goes wrong. If that path gets broken for any reason, the load has nowhere to go. And that is why a building sinks. It's exactly what happened with the Leaning Tower of Pisa, right? One side of its foundation was on weaker soil, so the path was incomplete, and well, it's been sinking ever since.
A broken path and a sinking building. That sounds pretty terrifying. So how do we make absolutely sure that path is never broken? Well, that brings us to the hero of our story, engineering. It's really that simple, and at the same time, that incredibly complex. The entire field of structural engineering is basically dedicated to doing one thing: creating that safe, unbroken path for the load. Engineers do it by studying the ground itself. Are they building on soft clay or a solid bedrock? And then designing the perfect foundation for the job, whether it's a shallow one that spreads the load out wide or deep ones driven way down to find stronger ground. So let's just put it all together. The problem is a load that isn't properly transferred because its journey to the ground is broken, which of course causes the building to sink. The engineering solution? To design a structure with a foundation that guarantees that path is always complete. That way, the load is properly transferred and the building stays exactly where you put it. Now, once you really get this one core principle, I'm telling you, you will start to see the entire world around you in a completely different light.
We are right back where we started. But this sentence isn't a puzzle anymore, is it? It's a fundamental law of physics. It's the truth that explains every single structure that has ever stood tall or ever failed. Now, we know exactly what it means. So just look around you right now. The chair you're sitting on, the floor under your feet, the ceiling above your head. Every single thing that is successfully standing up against gravity is a little miracle of proper load transfer. Your world isn't sinking because it's a massive, incredible system of completed journeys.
And that really leaves us with one final thought to chew on. We are surrounded constantly by these invisible paths, these brilliantly designed journeys of force. So take a look around and ask yourself, what unseen structures, what clever engineering is at work at this very moment, holding your world together?